Hey guys, we are back. We're finishing up, almost finishing up chapter 8. We're talking about geometric sequences and series this time. And a geometric sequence is a sequence where the ratios of consecutive terms are the same. So we're talking about if you take one term divided by its previous term, no matter where you are in the pattern, it will give you the same ratio. And we know the infinite geometric series or geometric series is the sum of an infinite geometric sequence. So remember, the sequence is the list of numbers and the series is the sum of all of them added together. So the definition of the common ratio, we talked about what that is. The common ratio, which defines a geometric sequence, right, is that the common ratio equals a term divided by the previous term. And it will have the same ratio as another term divided by its previous term, and so on. So you can pick any term. So any term divided by its previous term, and it will give you the same ratio as long as the ratio is not equal to 0. So let's go ahead and do example number 1. It says determine whether or not the following sequence is geometric, so meaning it has a common ratio. If it is, find the common ratio. So in order to see, we're going to check these two. I'm going to put a certain term and divide it by its previous term. We get that this ratio is 1/2 or 0.5. If I checked these two, negative 30 divided by 0, whoops, well that's undefined. Notice that these are not the same. So we say, no, these are, or this is not a geometric sequence, right? Okay, let's jump into the next one, the nth term. So we don't know what the nth term is, but we're talking some term of a geometric sequence has the form, and here's it. So to find any term, we say a sub n could be any term equals the first term times the common ratio to the n minus 1 power. Remember that n is the number of the term you're looking at. Okay, r is the common ratio of the consecutive terms of the sequence. So every geometric sequence can be written in this term. So it can be the first term, comma, the first term times one of the common ratios, the first term times the common ratio twice, the first term times the common ratio 3 times, and so on, right? So basically, if you know the nth term of a geometric sequence, you can find the next term by multiplying by r, the common ratio. Another way to say that is a sub n minus 1, or n plus 1, is the previous term times the common ratio. So let's write the first 5 terms of the geometric sequence, whose first term is 5, and the common ratio is 3. So we know if the first term is 5, that's our A1, we're going to be looking for A2, A3, A4, and A5. So let's figure out how we can do this. So we remember we multiply each one to the next term is multiplied by negative 3. So 5 times negative 3 is negative 15. If I multiply it again by negative 3, I get positive 45. Multiply it again by negative 3, I get negative 135. Multiply it again by negative 3, we get 405. Okay, so every time you want the next term, we just multiply by the common ratio. To find the 8th term of the geometric sequence when the first two are 15 and 12, here's what I know. I want to look for the 8th term. I don't know it. I know the first term is 15, and the second term is 12. We need to use this information so that we can find a couple things. One of the important things is we have to know that the first term is 15. We do need to know the common ratio. Well, I know that the common ratio is the ratio of a term divided by the one previous to it. I know 12 over 15 can reduce to 4/5. So now I have r. So remember that we can plug this into any nth term equals the first term times the common ratio to the n minus 1 power. So a sub 8 equals the first term as 15 times the common ratio is 4/5 to the 8 minus 1 power, which is like saying 15 times 4/5 to the 7th power. We plug that in the calculator. We get 3.145 to 5728, which we can round to approximately 3.1. Okay, make sure that you plug that in your calculator with the exponent. All right, let's do our last page of notes here. So the sum of a finite, remember finite is ending, geometric sequence. Remember the geometric sequence, we say this is the first term, the second term is the first term times r, the next term is the first term times r again, and so on. When we say that the sum of all of these is the sum of the nth to the nth term is the first term times 1 minus r to the nth power all over 1 minus r. So when we're using this formula, make sure that we know the index is equal to 1. If the index starts at 0, you must adjust for the nth partial sum. So instead of starting at 1, if they start at 0, that means instead of ending at the last number, you end at the number before it. So let's find this partial sum. We're going to use that formula that we listed up here. So if we know S sub n equals the first term, times 1 minus r to the nth power all over 1 minus r, we know n is going to be right here. So we want to find the partial sum to the 10th term. Now, remember how this right here, you're probably thinking, Lord, Miss Salz, I don't know what to do. I don't know what this looks like. Remember how this kind of looks like that a geometric sequence looks like a sub 1 times r to the nth term. So this is our a sub 1, r, and there's our variable. So we know a sub 1 is 2. Our r is 0.5, so we're going to go 1 minus 0.5 to the n is 10, all over 1 minus 0.5. And then when we plug that in, we end up with approximately 3.99, which is approximately 4.0. Okay? So you're going to decode that, and it looks like the geometric nth term, and we break that apart, and we know which piece goes where. All right, last piece. If we're talking about a geometric series, as long as the common ratio is less than 1, then the infinite geometric series looks like this, and we can find the sum of it, because if it's decreasing, we can find the sum. We know the sum of an infinite decreasing geometric series is the first term divided by 1 minus the common ratio. But if the r is greater than or equal to 1, then it does not have a sum. So for example, if possible, let's find the sum. So remember, we just said if the common ratio is less than 1, then it's the first term minus the common ratio. So, but do you see how this is the common ratio in here? So we say this is the common ratio, this is the first term, and that's our adjusted n minus 1 term. So we say S equals the first term, 9, all over 1 minus R is 0.25. So 9 over 0.75, because we know 1 minus 0.25 is 0.75. Plug that into the calc, and we get 12. All right, that's it for our notes today, you guys. See you back in class.